Hup. Have you ever looked out your window in the middle of October and wondered, why are all the leaves changing color? Or maybe you've just stepped outside on a brisk autumn day, feeling that cool air, and thought, wait, wasn't it just super hot a few weeks ago? It's a great question. Why do the leaves change? Why does the weather get hot and then cold? It all comes down to one big, amazing reason: the seasons. And today, we're going to dive into exactly why we have them. Let's start with those beautiful leaves. In the spring and summer, leaves are like tiny solar-powered food factories for trees. They're packed with a green pigment called chlorophyll. Chlorophyll is the MVP. It captures sunlight and uses its energy to turn water and carbon dioxide into sugar, which is the tree's food. This process is called photosynthesis. Now, as a side effect of all this green chlorophyll, it masks other colors that are also in the leaves, like yellows and oranges. They're there all along, just hidden behind the dominant green. So, what happens in the fall? As the days get shorter and there's less sunlight, the trees get a signal that winter is coming. Winter is a tough time for trees. Water can be frozen, and there isn't enough light to make photosynthesis worthwhile. So, the trees start to shut down their food production for the year. The chlorophyll breaks down and disappears from the leaves. And when the green fades away, guess what? The beautiful yellows, oranges, and even reds that were hiding underneath are finally revealed. It's like the tree's grand finale before it takes a long winter nap. The red and purple colors are a bit different. They're often created from sugars trapped in the leaves as the connection to the branch closes off. So, a sunny autumn day after a cool night can create the most brilliant reds. This brings us to the bigger picture. Why do the days get shorter and the air get colder in the first place? It all has to do with our planet, Earth, and its journey around the sun. A lot of people think we have seasons because the Earth gets closer to or farther from the sun. That sounds logical, right? But it's actually not true. In fact, the Earth is often closest to the sun in January, right in the middle of winter, for those of us in the Northern Hemisphere. The real reason for the seasons is something much cooler. The Earth is tilted. Imagine a spinning top. It doesn't usually spin perfectly straight up and down. It often has a little wobble or a tilt. The Earth is just like that. Our planet spins on an imaginary line called an axis, which runs from the North Pole to the South Pole. But this axis isn't straight up and down relative to our path around the sun. It's tilted by about 23.5 degrees. This tilt is everything. As the Earth orbits the sun over the course of a year, that tilt means that different parts of the planet get more direct sunlight than others at different times. Let's break it down. Think about summer in the Northern Hemisphere, places like North America, Europe, and Asia. During this time, the northern half of the Earth is tilted towards the sun. This means the sun's rays hit this part of the world more directly, almost like a flashlight shining straight down. This direct energy is more concentrated, so it heats the ground and the air much more effectively. The days are also longer because more of the hemisphere is lit up as the Earth spins. More direct sunlight for more hours equals warmer weather. That's our summer. Now, what's happening in the southern hemisphere at the same time? Places like Australia and South America are tilted away from the sun. The sun's rays hit them at a shallow angle, spreading the energy out over a larger area. It's like shining that same flashlight at an angle. The light is more spread out and less intense. The days are shorter, and the less direct sunlight means it's colder. So when it's summer in the north, it's winter in the south. Fast forward 6 months. The Earth has continued on its journey to the other side of the sun. Now, the situation is reversed. The northern hemisphere is tilted away from the sun. We get those indirect, spread-out sun rays. Our days become short, the air gets cold, and voila, it's winter. Meanwhile, The southern hemisphere is now tilted towards the sun, getting that direct, intense sunlight. They're enjoying their long, hot summer days. So, what about spring and fall? These are the in-between seasons, also known as the equinoxes. During the spring and autumn equinoxes, the Earth's tilt is neither towards nor away from the sun. It's kind of sideways to it. On these days, the sun shines pretty much equally on both the northern and southern hemispheres. Day and night are roughly equal in length all over the world. These are transitional periods, as we move from the cold of winter toward the heat of summer spring, or from the heat of summer back toward the cold of winter fall. So, let's put it all together. The Earth is tilted on its axis. As we orbit the sun, this tilt causes our hemisphere to lean either towards the sun or away from it. Leaning towards the sun gives us direct sunlight, long days, and warm summer temperatures. Leaning away gives us indirect sunlight, short days, and cold winter weather. And in between, we get the milder temperatures of spring and fall. Tilt. This tilt doesn't just affect the temperature. It affects everything about our planet's climate and ecosystems. It dictates when plants grow, when animals migrate or hibernate, and even our own human activities, from farming to deciding when to go on vacation. It's the reason you might be bundling up for snow while someone on the other side of the world is heading to the beach. 2. Elegant cosmic dance. Our planet's constant tilt and steady orbit create this wonderful, predictable rhythm of change that we call the seasons. So next time you see those autumn leaves, you'll know it's not just a pretty show. It's a sign that our little part of the world is starting to tilt away from the sun. Getting ready for a long winter's rest, all because of that 23.5-degree slant that makes our world so dynamic and interesting. Thanks so much for hanging out and exploring the science of seasons with me today. I hope this cleared things up and gave you a new appreciation for our amazing planet. If you enjoyed this video and learned something new, please give it a thumbs up. And don't forget to subscribe and hit that notification bell so you won't miss our next adventure. Got any more cosmic questions? Or what should I do in my next video? Drop them in the comments below. See you next time.